Okay, we will be covering transformation matrices in this video. So let's begin. Transformation matrices. Let us start with reflection. And reflection in x-axis. So always consider this basic square. This coordinate is x1, y0. This is x0, y1. So it is reflection in x-axis. So this point after reflection will stay here, and this point after reflection will come over here and become x0 and y minus 1. So reflection in x-axis, the matrix is, first you have to write this point, that is x1, y0, and then this point which was on y-axis, that is 0, minus 1. So this is the matrix of reflection in x-axis. So let's try one more. Reflection in y-axis. So again consider one basic grid. Again those same points, coordinates x1, y0, x0, y1. So when you reflect this in y-axis, you know this point stays on the invariant line or mirror line. This point right here, this reflects in y-axis and becomes x minus 1 and y0. So you always write the point which was on x-axis, that became minus 1, 0, and the point which was on y-axis then changed, so it is still 0, 1. So reflection in x-axis, this is the matrix. Reflection in y-axis, this is the matrix. You cannot memorize them, so please understand. Okay. Reflection in y is equals to x. Again, those same points. x1, y0, x0, y1. So when they will be reflected in the line y is equals to x, this point will reflect on this one, and this point right here on y-axis will reflect at this point. So after reflection, the point on x-axis becomes 0, 1. You always write the answer what happened to the point on x-axis, and the point on 0, 1 which was on y-axis became 1, 0. So this is the matrix of reflection in y-axis. Now let's jump to rotation. Rotation 90 degrees clockwise. So every time you have to take the same points. So this is x1, y0, this is x0, y1. So when both of these will rotate 90 degrees, this point will come here about the origin. So this is x0, y minus 1, and this point right here will rotate on this one. So the point on x-axis became 0, minus 1. The point on y-axis after the transformation, after the rotation, became 1, 0. Reflection in rotation 90 degree clockwise. Now rotation 90 degrees anti-clockwise. Every time same points, x1, y0, x0, y1. So when it is anti-clockwise, this point will become x minus 1 and y0, This point rotates and becomes 0, 1. So the point on x-axis, it became 0, 1. The point on y-axis, it becomes -1, 0. So this is the matrix of rotation 90-degree anti-clockwise about the origin. Done with 90, and then you have 180. Rotation 180 degrees. Same square, x1, y0, x0, y1. So after 180 rotation, this point will come over here and become x minus 1, y0. So x became -1, 0. And this point after 180 degree rotation comes over here and becomes x0, y minus 1. So 0, -1. So you have the matrix of rotation of 180 degrees about the origin. Reflection, rotation, translation has no matrix. It is a vector. So now enlargement. In enlargement, we have a positive scale factor and negative scale factor. It makes no difference what we are going to solve. The method is same for both. So consider this square x1, y0. This is x0, y1. So when this enlarges, x becomes k0 and the point on y-axis becomes 0k. So on x-axis it became k0, on y-axis it became 0k, where k is equals to scale factor. So these were the matrices. You can write this down at one place, but remember you cannot memorize them, so go through the process. Whatever the examiner asks you on spot, just solve them and you will be doing good. In case it is negative enlargement, just plug in the value of scale factor and no other difference. Thank you so much. Take care. Allah Hafiz.